Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole, and I'm from Calgary, Alberta. I hope you all enjoyed the Women in Engineering segments I did last month. They were a lot of fun to put together. My intent was to start a conversation where it's overdue and add to the conversation where it's already going on. Either way, we all have so much work to do to build more inclusive workspaces. I was recently promoted to associate at the mechanical engineering consulting firm I work for. It has me thinking a lot about management and inclusivity and how I can become a great leader. Luckily, there are a lot of great resources out there for me to learn and grow. I'm also working on another project focused on some of the topics I discussed in the Women in Engineering segments. It's really exciting, and I promise to tell you more about it soon. You can also follow me on Twitter or connect with me on LinkedIn for updates. Now that March is over, though, the regularly scheduled programming is back. This week's engineering news is about Ever Given. I think we've all heard about it, the container ship that got itself stuck in the Suez Canal for almost a week. First, a little about the ship. Registered in Panama City, Ever Given has been shipping containers since the fall of 2018, so not quite 3 years. It can carry over 20,000 shipping containers and is manned by a crew of only 25. This wasn't its first accident. It collided with and heavily damaged a ferry boat in Germany in February 2019 due to high winds. When it became stuck in the Suez, it was on its way from Malaysia to the Netherlands. On Tuesday, March 23rd, during a period of high winds and a dust storm, Ever Given lost its ability to steer. There seem to be conflicting thoughts on the cause of the ship getting stuck, and a formal investigation is underway. Not sure if you've ever driven a boat, but steering is a challenge. In my experience, you just kind of point the boat in the direction you want to go and hope for the best. Now, I'm sure cargo ship captains are far more qualified in ship maneuvering than I, but I just wanted to point out that it's not easy. Ever Given is 60 meters wide, and the canal can accommodate a maximum ship width of 77 meters. That means that Ever Given was only 22% smaller than the maximum ship width the canal could handle. This is important because even in the best of times, it's a pretty tight squeeze. When I first heard about the Ever Given being stuck, I checked out the canal on Google Maps. My first thought was, how does this not happen more often? In case you're wondering, the canal is single file with 2 spots that allow passing for ships going the other direction, and it takes roughly 11 to 16 hours to travel from one end to the other. Once the ship was stuck, the canal passage was blocked, and over 400 other ships were left waiting to get through. Think of all of that cargo just sitting there, waiting. We live in a time of same-day or overnight delivery, in a global pandemic where a lot more things are being ordered online than ever before. All of that said, I'm mostly interested in how they freed the ship. The ship was stuck on a diagonal. The bow was stuck on the east bank, and the stern on the west bank. A period of high tide, dredging of over 30,000 cubic meters of sand, and 13 tugboats ultimately freed the vessel. The stern was freed first on Friday night after extensive dredging. By Sunday, March 28th, they had started talking about lightening the ship as a worst-case scenario. Luckily, they were able to remove enough sand by the time the tides rose on Monday, and they didn't end up having to remove any of the containers. With the stern free, tugboats pushed it east while another set of tugboats pulled the bow west, eventually pulling the ship free after almost a week. Ever Given was then towed to a nearby lake for further inspection. Because of all of the dredging they did, once the Ever Given was free, the canal still had to be inspected before any more ships could pass as the depth of the canal had changed. Aside from the economic impact on global trade, this event has raised a lot of questions about the shipping industry and the canal itself. It's really interesting how this all works. It's like a window into an industry that I know very little about. I'm going to continue following this story, and pending the ultimate cause of the ship getting stuck, I may feature it on a future episode. I've included some links to articles I found on the Ever Given in the show notes, but really, just Google it. There's a lot of info out there. The whole world was watching. Now on to this week's engineering failure, the Triangle Shirtwaist Factory Fire in 1911. As I said in episode 16 about the Sunshine Skyway Bridge, sometimes the failure comes before the engineering, and that's exactly what happened here. The Triangle Shirtwaist Factory Fire changed fire safety and building codes for the better. In fact, the fire created and shaped a lot of those codes. I covered the Grenfell Tower fire in episode 4. It's an extremely tragic fire, and the investigations are still ongoing. At the same time, I found the design and engineering, or lack thereof, behind the fire very interesting, and we have so much to learn to prevent that type of devastating fire from happening again. Aside from shortfalls in building and fire safety codes and inspections, another thing that both the Grenfell Tower fire and the Triangle Shirtwaist Factory Fire have in common is that in both instances, the people in charge of the building, its occupants, and their safety were warned of the risks and did absolutely nothing to mitigate them. It's really a shame how some people in a position of power can treat others so poorly in the name of profits. And that even today, this is still going on. I mean, look at Amazon. They are currently under fire after it came out that their employees were going to the washroom in their trucks because of the immense delivery quotas placed on them. Jeff Bezos has a current net worth of $177 billion. That's billion with a B. $64 billion up due to the pandemic. You'd think he could allow his employees enough breaks to use a proper washroom. But I guess treating people like human beings is too much to ask. Sorry, got off on a bit of a tangent there. Back to the Shirtwaist Factory Fire. The year was 1911. The factory was owned by Max Blank and Isaac Harris. They made women's shirts, which at the time were called shirtwaists. They looked kind of like a dress without the skirt part. Believe it or not, women wearing pants as an everyday clothing option didn't really catch on until the mid-20th century. I couldn't imagine. It's so hard to move around in a dress. Plus, dresses don't really go with steel toes and a hard hat. The factory employed 500 workers. Most were women. Some were as young as 14. They worked 6 days a week, 9 hours per day during the week and 7 hours on Saturday. Their pay was terrible, even for the time. For 52 hours of work, they made $7 to $12 a week, which equates to about 13 to 23 cents per hour. In today's money, that's $3.60 to $6.30 per hour. The Triangle Shirtwaist Factory was located on the 8th, 9th, and 10th floor of the 10-story Ash Building at the corner of Washington Place and Green Street in Washington Square, Manhattan, New York City. Today the building is called the Brown Building, and it makes up part of New York University. It's also a registered National Historic Landmark and a New York City landmark. At the time, New York City law dictated that buildings 11 stories and higher had to have stone floors and metal window frames. But the Ash Building, being only 10 floors, was permitted to have wood floors, wood trim, and wood window frames. I don't know if you know this, but wood is very flammable. It kind of freaks me out how fast fires can rip through wood structures. But it's a cheap construction material and it's easy to work with, so it's very, very common. The code also required buildings with a floor area greater than 930 meters squared to have 3 staircases or exits per floor. Even though the Ash Building's floor area exceeded that 930 meters square, the architect pleaded for approval for only 2 interior staircases, as there was an outside fire escape that could be reached by window. Even though said fire escape terminated at the 2nd floor, which wasn't even the only flaw with the fire escape, but more on that later. Labor laws at the time required factory doors to open outward, quote, if practical. The architect argued that each landing was only 1 stair width from the door, so doors had to open inward, and it was ultimately permitted. When you're one person opening a door, the direction of swing isn't overly critical. But when you have a mass of people pushing towards an exit, It's nearly impossible to pull the door towards that pushing crowd in order to open it. People are panicking, and many of those pushing can't see what's happening at the door. Just look at what happened at the Who concert in 1979 in Cincinnati, where 11 people died and 26 others were injured when a large crowd of people rushed to the doors. So that's the list of how the workers were failed during the factory design process. But once in operation, there were other problems. The doors to the stairwells and exits, those doors that opened inwards, were locked during the day, a then common practice to prevent workers from taking unauthorized breaks and reduce theft. The rags from cutaway cloth materials regularly accumulated on the floors and in collection bins. The last time these rags were removed from the factory before the fire, they had amassed just over 1,000 kilograms. The rag bins hadn't been emptied for 2 months before the fire. The factory was also crowded. The aisles were narrow and obstructed, and there were partitions in front of doors and elevators. In 1909, a fire inspector recommended that the doors remain unlocked during the workday and to have regular fire drills to practice emergency exiting. But no actions were taken. I don't think I've participated in a fire drill since high school. They are an underrated tool for safety. In an emergency, our natural reaction is to panic. But if we've practiced exiting, we know where to go and what it looks like. It takes some of the uncertainty out of the equation. As a Type A personality, I find knowing the plan in an emergency to be comforting. In 1910, 1,243 coat and suit shops were investigated. 9 days before the fire, a New York City paper reported that 99% of those shops were deficient in safety. Many had only one exit, many had locked doors during the workday, and 94% had doors that opened inward rather than outward. At 4:40 p.m. on Saturday, March 25, 1911, a scrap bin under one of the cutter's tables on the northeast corner of the 8th floor caught fire. It held 2 months' worth of cloth cuttings at the time. The fire marshal believed that an unextinguished match or cigarette butt landed in the bin. A fire in the bin was not uncommon, but this time it spread quickly. They tried to extinguish the fire with buckets of water, to no avail. The fire quickly spread from the rags to the cutting tables, to the cloth patterns hanging on wires above the tables, to the wood floor trim, sewing tables and partitions, and ultimately to the ceiling. Workers on the 8th floor rushed for the doors. One was locked. Once they managed to unlock it, it opened inwards, and everyone rushing to the door made it difficult to open. Some people exiting fell at the 7th floor in the stairwell, creating another blockage to exit. In all, 125 workers escaped down that stair. Some workers from the 8th floor climbed out windows to the fire escape. One worker fell down to the courtyard below. Others went down the fire escape to the 6th floor, went back into the building through a window, and down the staircase. We'll get to the 9th floor in a minute. Meanwhile, on the 10th floor, the fire was reported to the executive offices via a phone connection. Many on the 10th floor called for the elevators to escape. The elevators made so many trips that by the end, the operators were overcome by smoke and exhaustion. Many from the 10th floor escaped to the roof and were rescued by an adjacent building. Of the 70 workers on level 10, only one died after they jumped from a window. Considering how many died in this fire, this is kind of a mini miracle in the middle of a tragedy that only one person from the 10th floor died. And it goes to show that the massive loss of life was preventable. Oh, the 9th floor. In short, it was forgotten. They had no idea what was going on below or above them. It wasn't until flames leapt through the windows that they realized there was even a fire. The only telephone communication to the 9th floor was via the 10th floor switchboard, and they forgot to call. There were 260 workers on the 9th floor, as well as 8 double rows of sewing machines and 22-meter-long tables that took up nearly the entire floor. If you were working on the south end of the floor, the only way to leave was to walk all the way back to the north end where the exits were located, and the aisles were blocked with chairs, wicker baskets, and other items. One worker from the 9th floor walked down the stairs at quitting time, saw the fire on the 8th floor, and just kept walking down the stairs. He didn't think to warn others until it was too late to get back up the stair. He was the first 9th floor worker to learn of the fire, but he didn't tell anyone else about it. So it kinda doesn't count. As flames swept through the window, 150 people headed for the Green Street exit and more than 100 made it out. The Washington Place exit was locked. The fire escape, which was jammed with people and hot from the fire, pulled away from the building and partially collapsed, sending people flying to the courtyard below. Remember that fire escape that the architect convinced the building apartment was a viable third exit? Yeah, it just collapsed off the side of the building. Because of all of the people using the elevators from the 10th and 8th floors, the people on the 9th floor couldn't get into the elevators. Some jumped or were pushed into the elevator shaft. This was back when the elevator doors were gates operated by people, so it was possible to get into the shaft without the elevator car there. Many 9th floor workers climbed out windows and jumped to their death, breaking fire department nets and smashing holes in the concrete pavement and glass below. At 4:45 p.m., a passerby saw smoke from the 8th floor and notified the fire department, but their equipment was only good for fighting fires up to 7 stories. Something similar also happened at the Grenfell Tower fire, which is just baffling to me. You can't will a fire to stay below a certain height. As an emergency department, you should be prepared for all scenarios. Despite the fire department arriving at the fire relatively early, 146 people lost their lives that day, from the fire, smoke inhalation, and from falling or jumping from the building. Of the 146 people who died, 123 were women and girls, and 23 were men. Most were Italian and Jewish immigrants aged 14 to 23, with the oldest victim being 43. Both of the factory owners were in attendance the day of the fire, as they had invited their children for the afternoon. They all survived after fleeing to the roof. As tragic as it was, those lives were not lost in vain. The fire led to legislation and improved factory safety standards, including the creation of the International Ladies Garment Workers Union, which advocated for better working conditions for sweatshop workers. The unions intensified their activities to bring about change and ultimately revolutionize the garment industry. Immediately after the fire, New York City residents formed the Committee on Safety. In June 1911, 3 months after the fire, the New York governor at the time created the New York State Factory Investigating Commission to look at the conditions of all factories. They even had a $10,000 budget to carry out their work. In October 1911, the Sullivan-Huey Law was passed, which established the New York City Fire Prevention Bureau and expanded the powers of the fire commissioner. This was a first in the United States. It's one thing to investigate safety, but if that group, or really any other group, doesn't have the ability to enforce improvements in safety, then the recommendations don't really go anywhere and things don't ever really improve. Members of the National Fire Protection Association, which formed in 1896, were shocked but not surprised by the fire. In 1912, they published their first Safety to Life publication highlighting the importance of exit drills in factories, schools, department stores, and theaters. That said, there was still no specific National Fire Protection Association committee dedicated to life safety exclusively. That happened on June 23, 1913. The committee spent the first year analyzing fires involving loss of life, attempting to determine the cause. They released their first report in 1914, highlighting the importance of egress, fire sprinklers, and preliminary specifications for exterior fire escapes. The report found that the laws at the time were extremely deficient on building egress. Several states even reported that they have no legislation on egress, interior or exterior. Regarding fire escapes specifically, the committee found that the iron heated quickly and the expansion of the bolts and fasteners caused the frame to pull loose. That said, there were existing older buildings with only one interior exit that could benefit from a fire escape as an alternate path of egress. I think the option to retrofit a building with a fire escape is a good idea, and therefore rules should be established around the construction of those fire escapes. But on new builds, fire escapes should have been banned in lieu of 2 or more internal staircases. Calgary is a relatively new city. We have very few fire escapes. There are some here and there where existing buildings were converted into condominiums, but for the most part, our buildings have interior staircases to allow exiting. You may be wondering if an interior stair is better, because that's usually where the fire is. but stairs are required to be built with a fire separation of at least 1 hour, but up to 3 or 4 hours in some instances. This means that the materials used to construct the stair are designed to take at least an hour to burn through, allowing enough time for people to exit the building safely. In 1927, the National Fire Protection Association released its first edition of the Building Exits Code. Today they have over 300 codes and standards, ranging from fire prevention to extinguishing, intending to minimize the possibility and effects of fire. The National Fire Protection Association is a really fantastic resource for anyone in the building construction industry. Their codes are accessible online for free once you create a login, and they're not hidden behind a paywall like many others. Look, I get it. Someone has to be paid to write the codes. But in my opinion, if you want people to follow them, you have to make them accessible. And I think that what the National Fire Protection Association did by making their codes available online for free was really smart. I read some chapter or another in the National Fire Protection Association code at least once a week. Usually it's related to fire sprinklers, but also fire extinguishers, commercial kitchen exhaust, or even chemical fire suppression. So there you have it, the story of the Triangle Shirtwaist Factory Fire, a tragic fire that changed the shape of building and fire safety forever. It certainly wasn't the only fire to impact safety codes, but it was definitely one of the more significant fires in North America. Part of me wishes I could go back in time and prevent that fire from happening in the first place. But I also realized that if it or any other major fire hadn't happened, where would we be on safety? Humans seem to be a reactive species. I wish we could be a little more proactive. Maybe we're just stubborn and don't want to see the potential problems in front of us until they're a major issue. But we have to be better. We should and can do better. Be the change you want to see in the world. For photos and sources from this week's episode, check out the show notes or head to failurology.ca. If you're enjoying what you're hearing, please rate, review, and subscribe to Failurology so more people can find it. If you want to chat with me, my Twitter handle is @failurology. You can email me at thefailurologypodcast@gmail.com, or you can connect with me on LinkedIn. Check out the show notes for links to all of these. Thanks everyone for listening, and tune into the next episode of Failurology, where I will cover the Westgate Bridge in Melbourne, Australia. This story is so ridiculous, I almost didn't believe it. But more on that next time. Bye everyone. Talk soon.